Evening, and how are you? Today we are proceeding with our, we are continuing actually with our series of seminars on different methods that we could, that we are studying actually, that we'll be using in our research analysis, and how we could take advantage of these methods and use them in publication. And today we are discussing about mediation analysis and how it's actually done, what it means. So in our menu, we're looking at what is mediation, how it's done, how do we theorize about mediation, how do we formulate hypothesis about mediation, and how we're going to do some practice session using some software, and I'll recommend some resources to you. And if time allows, of course, I'll show you some articles and papers that have been published using mediation, and some using moderation, and some using meta-analysis. And then, of course, I will have a session of question and answers. So we don't expect this to be very long today, because we don't have so much to cover. We'll be simply touching what is important, okay? Now let's look at some definitions and concepts. Now, yesterday we looked at these concepts, the distinction between moderators and mediator. Maybe as a way of reminding you, I should say again, moderator variable is sometimes called a separator. So when or for whom a variable X most strongly predicts an outcome or a criterion variable, that's the dependent variable, it is strengthened the value of that dependent variable, or rather that beta, the relationship, then we'd say that's a moderator. Now, of course, a mediator is simply a process by which a predictor variable or independent variable of some sort cause or explain the outcome, okay? Now, generally, we ask a question like, does X predict or cause Y? See? So we have to go beyond such a simple question, which is normally what we do in simple regression. So with moderators, we address the question when or for whom X causes Y. But with mediators, which is our topic today, we address questions how or why X cause Y. So your hypothesis and your theorization in this process will have to address things of how and why between the relationship between two variables. That's an independent and a dependent variable. And therefore, mediation mostly is trying to study the transmission, the effect transmission mechanism through various means. It could be indirect or through direct means. But particularly, if such transmission are done indirectly, then we could infer the presence of mediations or mediator. So mediators normally carries the indirect effects between X and Y, okay? Well, actually the direct effect is carried by the variable themselves, if it's there. See, there are several possibilities. Now, talking about mediation, what is a mediator variable? Let's start there properly and go through, okay? So a mediator variable is the variable that causes mediation in the dependent. and the dependent variable relationship. So in other words, it explains the relationship between these two variables. So when we say that the impact of independent variable on dependent variable is not direct, and it is through another variable, that third variable is considered to be a mediator. Okay? We know that in normal social life, we always have mediators. You can take it from such metaphors and try to conceptualize it. If you have two people's dating, for example, or maybe in conflict or whatever, there are always mediators, human mediators, by the way. They are carrying information between two people. So using that analogy, you can see even in concepts and in variables and factors, for example, in research this way, we normally have variables that are mediators. They are carrying in effects between other variables indirectly. Okay, that's the idea there. So indirect or mediated effects constitute a type of relationship between constructs that often occur in social science research. Now, the methods for testing mediation have become more sophisticated. There are many methods which I'll show you, maybe 7 or 8. And there are approaches and there are classifications of mediation, which you have to understand. Okay. Then there's what we call as the mediation model. So mediation model has become almost mandatory in the contemporary literature and research endeavors for those who want to publish and for those who want to do research, whether in for master's degree and for PhD. Normally, mediation processes and models tend to capture reality, okay? Because in social exchanges, in society, and even in business, there are many mediatorial processes between variables, events, institutions, etc. So mediation is just one, but also moderation is just another effect, among many other effects, which are beyond the scope of this series of seminars. So mediation is just one of those. So to understand the relevance of testing mediating effects, it's first necessary to understand what mediating effects are, because the central issue of mediation analysis, it assumes a sequence of relationships in which an antecedent variable, which is the independent variable, affects a mediating variable, which then in turn affects a dependent variable. So you have, we'll be using letters X to mean the antecedent variable, which is the independent variable. And we'll be using letter M to mean the mediating variable. Then we'll be using letter Y to mean the dependent variable. So the way this works is that X affects M, and then in turn, M affects Y. In that way, M is a mediator. And that process between X and Y through M is called mediation process. You can,
Dr.
2007, he has some good thesis on that. Yes?
Slide is not seen.
You can't see the slide?
Yeah.
Other people's, can you see?
Yeah, we see it.
Yes, we see.
I see. I see,
but
ended
it's
with
not running.
Kinon.
I see
Not
it.
running.
It's not moving. It's not moving.
What I see is from by Mark Kinon and the others, 2007.
Yes, that's why it's still there.
Okay.
Now, so that's what I've been explaining, the relationship between the two variables, okay? X and Y through M, okay? X and Y through M, okay? So we're moving to, okay, so we're saying mediation establishes how or why a variable causes or predicts the criterion variable, okay? We will see some specific examples as we go. So mediator is the mechanism by which predictor causes or explain the outcome. Okay. So for example, we are talking of X and Y. Now Y is our outcome variable. And
yani viongozi, hata bosi wangu ambaye angenipa hela kidogo akushinda ofisini.
now I think today we don't have the other guy who will be muting you. So what I'll do, if I get you, I simply remove you. That would be the easiest because I can't do both things.
Sasa mimi nakusalimia lakini uingize issue ya C3 bwana.
I don't know where he is anyhow.
Nimwambia kanisa mko wakati.
Okay, so we have, let me find a person to make him a co-host. Probably, I don't see anybody. Mr. John, or maybe John or Karamagi. I want to make you a co-host so that you remove some people those who are speaking, okay? Mr. Karamagi, are you happy with that role? Mr. Karamagi, or maybe who is close? John? Who should I make a co-host?
I can do that.
Karamagi, okay. Okay, so we have Mr. Karamagi as a co-host, which means if somebody speaks, we'll simply remove you. So just remove them and to save time, okay? Okay, so mediator is, so we're saying a mediator explains why or how. And now we have the okay, so we have some predictor here. The predictor, first we would normally envision predictor versus outcome, then predictor, mediator, then outcome. So that would be, let's say, for example, parent is drinking. Then you have a mediator called family conflict. Then you have self-esteem, low self-esteem, okay? That's an outcome. That's just an example, okay? First, you have parent drinking. That's the parent is a drunkard. And then the Y variable is low esteem. And therefore we ask ourselves, does family conflict, let's say between a wife and a husband is mediating the relationship between parent drinking and low self-esteem, okay? that would be probably something from psychology or something. Okay. All right. Now, I'm trying to pick a pen here. Okay, point. Let's take this. Okay. So mediation. Sometimes you can use multiple mediators to make a model. I'm sorry. You're not supposed to when you're designing mediation, it's not necessary that you should use mediations or multiple mediators in order only to make your model complex. Okay. You have to start from theory and come up with reasons and rationale and propositions as to why there's a mediation. You are not also to start from statistical manipulations and testings only. So the best approach is mainly starting from theory and then moving on to testing the mediation theories. So it must be the need for a mediator in your model, in your research, or in your paper must be justified upfront or a priori by responding to key questions. First, why a mediator is needed. So you have to, there must be a reason. And two, which variable should be considered the mediator and why? Because between M and X, any of the two can be a mediator of the other. Because say for example, M is affecting Y, and also because they are both rightfully independent variables, okay? X is affecting Y, M is also affecting Y, but now which one is the mediator of the other relationship, okay? So it is possible that X is also a mediator of M on Y, but also it's possible that M is a mediator of X on Y. So you have to know which variable is the mediator, and we shall see how to discover that, okay? So you need some forethought about the relationships. Now, among other issues that you need to consider, reliability and validity of the instruments and sample size are key issues one must be aware of. Reliability and validity, because you know how to establish validity and reliability of your variables, your constructs. You could use Cron-Bunch alpha, you could use variance analysis, or you could even use some other formulas, or even factor analysis, principal component analysis, etc., to establish how the several indicators of the same variables are measuring the same thing. Of course, sample size also will have some effects on the statistical significance. So the smaller the sample, probably you have less likelihood of statistical significance, but the larger the sample, the better. Okay, so let's look at modeling relationships. How do we normally do this? Now, this is normally the beginning model. That's X affecting Y. And normally this relationship is denoted by the letter C. Now this is how even softwares would normally denote this C, which is a beginning model. I'll show you that later, of course, but I'm just trying to show you ahead of time so that you're aware of that. Then, the mediator is always denoted by M. So if you have several mediators, you could have M1, M2, M3, etc. But also you have to note that the relationship between X and M is noted as A, that relationship, okay? Then the relationship between M and Y is noted as B. And then the relationship between X and Y in the presence of M is the C complement, okay? So it's different from this C. This C is noted in the absence of the moderator M, all right? But this C, the C complement, is considered in the presence of the moderator M. Okay. So this is an example that we are trying to discuss. Okay. How you would normally look at that. So you want to see the connection between parent drinking and the low self-esteem via family conflict. Now that is normally called the indirect effect. Okay. Now, some literatures are discouraging calling this partial effects. So you'd call it indirect effect. Okay. Then parent drinking towards self-esteem, that's the C complement. This is called the direct effect. Now, normally we tend to avoid words like total effects and partial or full effects, because if you say this is this indirect effect and this direct effect makes a total effect or full effect, that is not realistic, because there are possibility of ignoring the presence of other mediators, because it's possible that there are several mediators, not only family conflict, there could be another thing. So that's the language thing, which I will note also later as well. This is a simplified model. So you may also see this being depicted this way, X affecting Y through M, all right? Now, when do we test for mediation? Now, the language that is primarily used is when you say total effect, although it is criticized, actually what we mean by total effects, we mean this is referring to the effects of the independent variable on the dependent variable without the presence of the mediator. That is the C. This is this one, okay? Now, that's the first one. The second one, the direct effect, refers to the effect of the independent variable on the dependent variable in the presence of the mediating variable in the model. That is C complement, which is this one here, okay? And then indirect effects, that one refers to the A-B connection. That's the indirect effect. Okay. Now, the primary procedure that is normally used maybe to try and teach mediation before you go to the more advanced and complicated ways of testing mediation, we normally look at Baron and Ken procedure, okay? Now, this helps, although it is simplistic and sometimes may not be too realistic, especially when it is brought in real life setting. Its significance is in its simplicity and in its importance when you are demonstrating what we mean by mediation and etc. and how we are testing. Okay, so here the steps are: first you start with X on Y, you test per C. Okay, with the absence, of course, of M. And then now you test past A, that is X on M. And that's regression, okay? You're regressing actually, X on M. And then X and M on Y. See, so you have this X and this M on Y. So you'll have two variables, this and this against Y, okay? And then you simply, so you have X and M on Y, and then you test path C. The first one you're testing path B, and then the second one testing the path C complement, this one. So we'll be testing this and this when they are running together. But that is the step 3 and 4, okay? Using the same regression equation, of course, in part 3 and 4. But in part 1, and 2, you're using the X on M. I mean, in part 2, you're using the X on M regression. But in part 1, you're using the X on Y in the absence of M. Okay, so that's the idea there. Now, number of hypotheses to be tested. There are several approaches. There are 3 particularly approaches that are used, but there are 2 approaches which are proposed, okay, to test, or rather to hypothesize and test the relationship, okay? So you have the segmentation approach. You can read the Rungutusanatham et al. 2014. He has a good digestion on that. But also you have the transmitter approach. On the same author is documenting that. So you can as well read in Ramaya et al. In 2018. That's where Rungutusanatham et al. Was quoted by these other guys. Okay. So let's look at the segmentation approach. As the name suggests, that means you're testing across segments. You consider these parts as segments, okay? Particularly considering this model, that one, and this one, okay? The 2 one, this one, and this one. Now, so in the segmentation approach, you'll have at least, okay, at least 3 hypotheses for 1 mediator, okay? If you have 2 mediator, you'll have 6 hypotheses, or maybe 5, it will depend. Let me show you. Now, hypothesis 1, you're testing the effect of X on M. And then, so the example will be there's a positive effect of X on M. And you must be clear on the direction as well, okay? Whether it is positive or negative, okay? That is A. That's the A part. Hypothesis 2 will be the effect of M on Y. That is, there is, let's say, for example, a positive effect of M on Y. All right. Then hypothesis 3 would be actually the mediation effect itself. So we'll be saying, you have 2 examples here. Example 1, they're giving actually two examples, these examples. So you say M mediates the relationship between X and Y. So you are testing the mediation. M mediates the relationship between X and Y. Of course, that's how to state a hypothesis, but I'll show you how to actually statistically see whether there's a mediation. Example 2 would be, for example, X has an indirect effect on Y through M. And many other ways of language which you can use, but you see the theme is there. You are trying to combine the 3 variables in some way, okay? The M, the X, and the Y, okay? So there you're testing the mediation effect. Then the second method is the transmitter approach, okay? In which you're simply testing the transmission or the intermediation of the effects between X and Y. So you'd say, for example, M mediates the relationship between X and Y, or X has an indirect effect on Y through M. So the transmitter approach simply pick the last part of the segmentation approach and makes that the whole thing. So you'll have only 1 hypothesis for the transmitter approach, okay? And then you can actually use hierarchical regression analysis to test mediation, all right? By hierarchical regression, you mean they're either hierarchical or stepwise regression. By that, you mean you put each independent variable or mediator in turn, step by step. So the first regression, you have X on Y. That's the C connection. the second regression, you also have X on, you have X on M, that's the mediator. That's the A hypothesis or A direction. That would be your second regression. And then the third regression will be your mediator to your outcome, okay? That's part B, all right? While at the same time, of course, controlling for the predictor, that's parent drinking, the predictor X. And then regression 4, actually, you'll have the predictor, mediator, outcome. So you'll have predictor and mediator as two independent variables, and then the outcome. And then you observe. So we'll show you how to do that, okay? Now, this is an example of how you do implement these steps. You can use specialized software, as we shall show you, or modules, or you can just run these steps in normal regression, and you will be able to achieve the same thing, okay? So, step 1, that's the first regression. Let's say, for example, hoping that you remember the dependent variable is low self-esteem, okay? That's our dependent variable, okay? Self-esteem, which is our Y, okay? Now, parent drinking is our independent variable. And in this example, the beta and standardized beta is 2.5. The standardized beta is 0.18, and it is statistically significant. And so this will be step 1. And this is path C, all right? Hope you're following. And then you move and do regression number 2, which is path A, that is X on M. So in this case, the dependent variable is the mediator, that is family conflict. So in this case, you have parent drinking regressed against family conflict. Your unstandardized beta is 1.9, your standardized beta is 0.12, and it is statistically significant, okay? And the R square change is, that's the R square, okay? The R square. Okay, they are statistically also significant. Of course, the model, I mean. Then in step 3, you take the dependent variable as low self-esteem, okay? That's your dependent variable, the Y. And in here, you're including 2 paths, path B, which is M to Y, and path C complement, which is X to Y. So this one, we are doing here now some comparison, okay? This is what in step 1, this is what we achieved in step 1, okay? This first thing, okay? Before you confuse probably. This one, 2.5, 1.8. So I've brought it here so that you compare this with this. But actually this regression that we're doing in regression 3 is actually in this step 2 here, okay? You have parent drinking, that is C complement, path, that is the path. And then you have a family conflict. Now that is path B. And the value is 3.1 and 1.2, 0.12. This is significant, this is not significant, okay? Now you'll see that there are changes between the paths. So for example, the C and the C complement, the values have changed. This was significant, now it is not significant, okay? Of course, family conflict is significant. Now, what does that mean? Okay. So the relation of predictor to outcome disappears. That is, becomes insignificant when a mediator is added to the equation. That is the total mediation. That would simply imply that if you see the decrease, okay, where I was, where am I? I'm actually here. Okay. If where am I studying? If the mediator, that is part B. Okay, if the mediator, okay, we'll discuss this later. Let me reserve this first. Okay, let me finish with this one first, okay? Now, low self-esteem, in here we want to establish if there is a partial mediation, actually, I mean mediation, not moderation, okay? Mediation, not moderation, because you're studying mediation, okay? Now, in regression 1, these were the results. In step 2 of regression 3, we had parent drinking, the value is 0.1 for standardized beta, family conflict is 0.9, okay? In this case, of course, we are controlling for predictor variable, and the mediator, which is family conflict, is related to the outcome, and it is statistically significant in this case. Yeah? So you need to note that the relation of predictor to outcome decreases. This is what I wanted you to note. When a mediator, not moderator, when a mediator is added to the equation, okay? That is the relation between the predictor, that is X to Y, which was initially 0.18, this one, decreases when a moderator is added to the equation. It decreases to 0.10, okay?
Okay.
And therefore, you have to check if this decrease is statistically significant, okay? As you can see, yes, it is statistically significant. Now, that is a way of confirming that there is actually mediation in this process. There is mediation in this process. Okay? But also you could use the Sobel test calculator, okay? Now this, well, it's a calculator in a sense that you can simply calculate because it's simply multiplication and division. But also in softwares, you have it there, which means we can actually implement it, okay? So to test whether the indirect effects of the predictor on the response variable via the mediator is significantly different from 0, you need to do the following, okay? So you need to have values A, that is representing the raw and standardized regression coefficient for the association between the predictor and the mediator, that is X to M. That's the, you take the unstandardized beta value, and then you have the SA, which is the standard error of A, and then you have B, which are raw coefficients for the association between the mediator and the response variable. That is the connection between M and Y, when the predictor is also a predictor of the dependent variable, okay? And the X, okay? And then you take the SB, it's the standard error of the B root, okay? And then you put those information in that calculator, and that will give you some calculation and a way of deciding if.
Unasema nani kutoka wapi alifanyaje kwenye guest ya nani? Umesema mtu kutoka wapi?
I'm waiting for you to finish. That means just... Okay, that's much better. So you can use also the Shroud and Bolga. I mean the.
Ule mpira anao nani? Anao gani?
Noise.
Ule
Nyamizi Kazungu, spares sometimes, please. Behave yourself.
I'm done. Efrem, habari yako?
Okay.
Sorry, doctor. Can I ask you just a bit, a question?
I think reserve the questions so that you ask at the end because of time. I will have questions and answers at the end. Okay.
Okay, thank you.
Yeah, this is another example. These it's the same type of analysis that could be done stepwise and how you normally see and compare the different values and see the decrease, for example, from the first path to the final path. And this is the way you would normally test for a mediator or a presence of a mediator. Okay. Okay. Now, maybe well, you can also calculate if you want to know the percentage of mediation. But now let's just continue here. These are path A, path B, and then path C. So A times B divided by C, and these are your beta values from the different paths, and then you'll be able to establish the percentage of mediation that is there. That is the indirect and the direct. So this will represent the indirect, and then the other complement, which would be 26, is the direct. So both of two will make a total effect between X and Y. Okay. I need to move on to something, I think. These are things that you can do, some ideas. I just want to pass through them because of time. So some of these ideas we've already spoken about. Okay. Some limitations, of course, of this method are here. But I want to take your attention to some methods, the BK method, the JMB method, the Sobel test, the DOP method, bootstrapping method, Monte Carlo simulations, Bayesian methods. All these are methods which can be implemented through statistical softwares and modules like Jamovi, Processing SPSS, SmartPLS, Adanko, etc. Now, we will not deal with, I will show you their steps, but I'll also show you some of them in the software and how you simply implement them. Okay? This is just an illustration which I don't want to there's a lot of noise. I don't know what you can do. I don't know what you can do. Okay. Let me see. Okay. Now, this slide, okay, contemporary literature on mediation advocates that complete or full and the partial mediation concepts have little value and should be abandoned, okay? You can look at these references. Why? Because if you say there's full mediation, that will tend to imply that the researcher has completely explained the process by which X influences Y through a set of mediators that you have identified. Well, actually, the possibility is that there could be more mediators, okay? So that's a note that instead of using words full or complete mediation, you would rather say total mediation and indirect, using words like indirect mediation, etc. And there's this diagram here. In this one here, I want to show you some possibilities, okay? While it is possible that we have, we have the relation between independent variable X against Y, and this is the error term, and this is your C complement. It's possible that you could have several mediators, okay? So you have your independent variable here, X, and then you have the first mediator, M1, and the second mediator. Of course, there are error terms as well, and the error terms. And this is your C complement. That's the mediation between X and Y in the presence of mediators, okay? Now, we'll also have to analyze path. For example, path A1, which is this link, path B1, which is this link, then path A2, path B2. So as you can see, you have, in this case, 1, 2, 3, 4, 5 paths, which you'll have to, these are 5 separate regressions, which you could run to test whether there is mediation in mediation 1 or in mediation 2 or both, etc. So we'll show you some procedure on how to do this, okay? Now, discussing these slides are actually explaining what I've been explaining in this first slide here, okay? So you can represent them as a set of equations, okay? You have I plus CX plus E1. Of course, you mean this is your independent variable. That's the first link. And then for mediator 1, of course, I simply means that's the constant value in a regression equation, okay? So I plus alpha 1 X plus error 2. So that will be mediation 1. This will be X on M. X on M1, this one. And this will be X on M2. And this one will be actually, you have the X complement, which is the direct path. And then you have the mediators both being included, okay? So you'll be testing beta 1 and beta 2 in this case to see if there are mediation there, okay? Now, this is what I've been explaining there, so I just don't need to repeat that. I think we can just continue on that. I see there's some chat here. Let me see if there's anything that needs some attention. Karamagi, I don't know, Shaban, mute your mic, etc. Anyway, okay, good. Now, the parameter C in equation 1, I'm referring to the previous slide. Okay. In equation 1 for figure 1A, denote the total effect of X on Y, such that a unit change in X results in an expected C unit change in Y. Okay. When X can be theorized to affect Y through the two mediation process of M and Y, as shown in figure 1B. Therefore, the total effect of X on Y can be decomposed in two portions, okay? One portion would normally is normally represented by C complement in equation 4. And then that's the direct effect of X on Y, such that we are holding M1 and M2 constant. A 1 unit change in X results in an expected C complement unit change in Y, okay? Then of course you have the second portion, which is the total indirect effect of X on Y, okay? Which is denoted by X, etc. So that's what we've been explaining. Now, specific indirect effect is a theoretically justified mediation process whose magnitude can be estimated. So you really need to justify it theoretically to establish an indirect, specific indirect effect. Let's say mediation 1 for variable 1, maybe M1 or M2 or M3. It could be more than 2 or 3 or 5, okay? Okay. So as the number of mediators increases, 2, 3, 4, 5, the number of specific indirect effects to be theoretically justified also increases, and to be estimated also increases. All right. So for example, with respect to figure 1B, the specific indirect effect of X on Y through M1 is estimated as A1, B1, okay? And that of M2 will be A2, B2, okay? Going back to this figure here. This is because the way you establish the presence of a mediation between X and Y is simply a multiplication of A1 and B1, okay? And then testing its value and looking at its significance, okay? So that's A1, B1, but also the other one is B2, A2, B2. That's A2 times B2. Okay, so that's what is meant by establishing the amount of effects between the two mediation, the two connections, okay? Okay. Then the total indirect effects of X on Y, X on Y, and the total effect of X, the total effects of X on Y, which is C, can then be computed, of course, using equation 5 and 6 here. So for example, you have theta X here. That is A1 times B1. Those are the roots within that diagram. And then you have plus A2, B2. This represents the total indirect effects. The indirect effects. This one, the indirect effects for moderator 1, and this is the indirect effect for moderator 2. All right. Now, in order to have total, that is C, without the complement, in order to have the total mediation, not full, see, not full mediation, not complete mediation, okay? Using the word total, okay? Total meaning the total of indirect and the direct. avoid the language full or complete mediation, because if you use that language, you are limiting the reality or the fact that there could be other mediators, okay, in that relationship. So C here stands for the full effects, not mediation actually, the full effects between X and Y, which is made up of C complement. Now C complement is the direct effects. Then theta X, which is this component here, is simply the total of indirect effects, which is the total of indirect, of the mediation effects, because mediation effects are the indirect effects, okay? So that's how you establish the total and establish it in terms of percentage. I'll show you how to do that in a software that would be much more easier, okay? Now, complete full mediation argument. This is what I've been actually saying all along. That is about using terms like complete or partial mediation when developing a mediation hypothesis. Instead, use direct or indirect, okay? Why? Because using that kind of language will constrain theory development and would not reflect reality, okay? But also, we're recommending the work by Zhao et al. 2010, who discusses about competitive and complementary mediation, which of course I'll discuss later very briefly. But in this work by Zhao et al., they discuss this thing in deep about competitive and complementary mediation. But I'll talk about it in some future slides. Now, how do we confirm mediation effects? Okay. Now, the central consideration of mediation analysis is that there is a significant relationship between the independent variable X and outcome Y through a mediator. That's the premise or the theoretical premise of mediation. You mean to say there is a statistically significant relationship between X and Y in the presence of a mediator M. So which means it's possible that the relationship between X and Y in absence of mediator M could as well be insignificant. It's possible. Or could also be significant. That is also possible, okay? Either way. Now, a statistically significant indirect effect, let's say at that level, should be taken as an evidence for mediation. And you can quote these guys, Pritch and Hayes and Zhao et al., okay? Should be taken as an evidence for mediation, as we discussed previously, okay? Then additionally, you have to look at the confidence intervals. This is another important condition to confirm mediation effect. The confidence interval. There is the lower confidence interval and the upper confidence interval. What do these confidence interval means? By the way, when you're running a regression, for each variable, the confidence interval are normally listed at the end. What are they trying to say? They are just giving you a range of possibility within which that value or that beta value may possibly vary, okay? So confidence intervals are important. If they are narrow, that means our precision is much more stronger. But if the intervals are wider, that will simply tell us that we have less precision in terms of, or rather confidence. That's why they are called confidence interval. How confident are you about the beta value? Okay, that's the idea there. So in this other point about confidence interval, what you need to look at is to see if the lower and the upper confidence intervals have a zero in between, okay? Which means is that, let's say, for example, the lower confidence interval has a different sign, and the upper the upper confidence interval has a different sign. Let's say, for example, the lower has negative, the upper has positive. or vice versa. That supports the presence of a mediation effect and vice versa, okay? I mean, that does not, I'm sorry. That does not support, okay. If the confidence interval for the indirect effects does not straddle a zero in between, okay? Which means the range, actually, the way I wrote here is contradictory. I'll have to change this one, okay? What we mean by that is that if the confidence interval between the lower and the upper, if both confidence interval are positive, let's say, for example, or if both confidence interval are negative, which means they do not straddle a zero in between, then there is a possibility of indirect effects, okay, or mediation. But if it is running between negative and a positive, then chances are less that you have indirect mediation. That's the idea, okay? Okay, so you could also use bootstrapping, which is a method, of course, of increasing your sample power, which can be implemented in softwares, okay? Well, I will not explain that one so much, but you have to be aware of that. Now, all these statistical programs can do all these. Now, when you're doing some multiple moderators, you must estimate specific indirect effects instead of total indirect effects. Take each moderator separately, mediator, and try to iron out and identify these mediators separately. Now, that can be done so automatically by softwares, okay? But if you're doing these mediations manually, let's say by using normal regression implementation strategy, then you have to be aware of holding constant some of the variables as the procedure requires. But the programs are programmed in such a way that they would normally do that automatically. So probably you don't need to waste so much time knowing how to hold constant, which, and etc. when you're doing that, but you just need to know how to use the software, okay? But also other things like Monte Carlo simulations and Bayesian estimations can also be implemented. These are specific estimation techniques and simulation techniques which can increase your sampling power. But I'm not going to discuss about those because those are somewhat advanced, so we'll not waste so much time on those. Now let's go to testing methods for mediation. There are several methods and steps, and each method has its steps. Now, I will not read all these and try to show you, but I'm just going to show you how the testing procedure is normally done. You have the C complement, A1, B1, A2, B2. Of course, here we are assuming the presence of two moderators, okay? Okay. And then these are paths actually, C complement, A1, B1, A2, B2, and then this combination. So this is the indirect effect for M1. This is the indirect effect for M2. This is the total effect actually. That's C. C complement is the direct effect when M1 and M2 mediators are hypothesized, okay? And A1B1 plus A2B2, that will be the total indirect effects coming out from M1, M, and M2 as moderators, okay? Now, these are methods. You have the BK methods, JMB methods, so Bell test. Of course, they're named after their developers, but they have advantages and disadvantages. So I have them here step by step. but I will not discuss them, and I'll just give you for you to read, okay? But these are the methods that you can easily implement in softwares. So these are the methods, okay? But the more you go, the below methods, like for example, bootstrapping, DOP methods, Sobel test, Monte Carlo, bias, these are the most stronger one. They have the most advantage, and they are more reliable. The more you go down, those are the best one, okay? Now, these are steps for each of the methods. If you want to understand them, then you have step one. For example, for BK method, you have to do step one. You estimate equation one to obtain C. If C is not significant, you stop. Then you step two, estimate equation two to obtain root A1 for M1. If A1 is not significant, again, you stop, etc., etc. Okay, those are steps. Then in step number 5, of course, you repeat for moderator 2. You repeat step 2 to 4. All right. So each step you keep the outcome. Okay, you keep them, etc., etc. So you can implement this strategy or procedure in any software, manually or whatever. But this is for JMB method. This is for Sobel test method. This is for DOP method. This is for bootstrapping method. This is for Monte Carlo simulation or Bayesian estimation, etc. Now, before we go to some practice session, I need to take you through some ideas on theorizing. Now, most people ignore this, but in any PhD or any publication, theorizing is probably the most important element in your article or in your paper or in your thesis. Theorizing. You have to know how best to theorize and come up with hypotheses. Therefore, whether you're doing moderation, whether you're doing mediation, whether you're doing conditional regressions or threshold regression or any other type of regression or any other types of relationship, you really have to know how to theorize from that angle. Now, there are recommendations on theorizing and testing and drawing conclusions. So there are here 18 recommendations, which I'll walk you through these because they're very important. That's a summary, but I'll walk you through one after another so that you see what we mean, okay? Which actually I'll discuss them somewhere. Are they here? Okay, I'll pick up from here later. That's recommendation 1 through 8. But before that, I need to come to this first and show you typology of mediations and non-mediation. You have to be aware of this. The first one is called complementary mediation. Now, of course, you know, if you're studying things of variables that have some complementarity, or maybe situations that have some complementarity, then you could try to hypothesize and explore about complementarity of mediation. Now, what we mean by that is that the mediated effect A, B, that is A times B, that value, and the direct effect C, both exist, and they both, and point at the same direction, which means if both are positive, then you have complementary mediation, okay? Root AB is positive. Root XY is positive. Then you have complementary mediation. Okay. Then you have competitive mediation. Okay. Now that's AX, that's, I mean, A and B, and then you have, that's the mediated effect, and then the direct effect, that is C, both exist, and point in opposite direction. When I say both exist, I mean they are both statistically significant. Yeah, that's the idea there. So even here in the first one, when we say both exist, we mean they are both statistically significant and they are pointing the same direction. So they are both statistically significant and they are both maybe positive or negative. Then that's complementary mediation. But competitive mediation is just a flip of the first one. You must have one being positive, the other being negative. Then you have competitive mediation. And then number 3, you could have indirect only mediation, which means mediated effect AB exists. That means it is statistically significant, but no direct effect. Okay, that is line C is not statistically significant. So which means that indirect only mediation is equal to total mediation, which means there's no mediation between X and Y. I mean, direct mediation, but there's only indirect mediation. Therefore, A and B must be statistically significant, whether negative or positive, okay? Number 4, direct only, non-mediation. That's direct effect C exists, but no indirect effect. So that would be a normal regression. You don't have mediation. You just have direct effect. All right. You should be able to also document that if it does exist or come out of your results. Number 5, no effect, non-mediation. Neither direct effect nor indirect effect exists. That is also possible. So A, B is not statistically significant, and also C is not statistically significant. So these are 5 typology. Now this diagram is actually a scheme around which can help you decide whether you have which type of mediation, okay? On these boxes here, you have complementary mediation, competitive mediation, indirect mediation, okay? So this side is dealing with mediation. But this side, their possibility are only 2. You have no mediation. That is, you have direct only, that's non-mediation. And then you have no effect, no non-mediation also. Okay, so how does this work? You look at your coefficient A, B. That is A, the beta of A and the beta of root B. You time them, A times B, and check if it is statistically significant, okay? If it is statistically significant, which is yes, you move to the side of mediation. If it is not, you move to the side of no, which is where you have non-mediations, okay? So if it's statistically significant, is yes, then you check, is C significant, okay? If it is yes, you move to this side. If it is no, you move to this and conclude and say there is indirect only mediation, all right? But if it is, if C is significant, that is the connection between X and Y, then you say, you go and check again if A times B times C, if it is positive, okay? Now it's not about significance, it's about positivity. Is it, because you have not to look, is it positive? If you times X times, I mean A times B times C, that product, is it positive? If yes, you have complementary mediation. If it is not positive, which means negative maybe. Then you have competitive mediation. Okay. And then evidence for hypothesized mediator. With this one, yes. So there's likelihood of mediation, etc., etc., etc. So the rest can be read and interpreted easily. Okay. Now, let's go to the 8 recommendations when you are hypothesizing for mediation. Recommendation number 1. Okay. It's just a reminder. It's not a new recommendation. Actually, that's what scholars are expected to do. That is, you are supposed to formally engage in theorizing exercise to formulate hypotheses about mediation effects before you proceed to tests and the other processes. Okay. You have to hypothesize mediation via either of the 2 approach, the segmentation approach, which goes step by step, or the transmitter approach. That's recommendation number 1. Okay. Recommendation number 2 concerns how formal hypotheses for mediation effects are developed and articulated. So just refer back to figure 1B there. So you need to examine the effects of X on M1 and M2, the effects of M1 on Y in the presence of XC and holding M2 constant, the effects of M, etc. All this kind of stuff. Okay. Then determine the statistical significance of A1. Those are roots, connections. A1, A2, B1, B2, and C. That's that is of your primary interest, and whether or not the combination of A1, B1 or B2, I mean A2, B2. Those are the mediation, the mediation roots, the complete mediation roots for each mediator. Whether it is statistically significant, that will be of secondary interest. Okay. So for brevity, you would normally use the segmentation approach if you want to go step by step. All right. But alternatively, you can use the transmitter approach, in which case you'll be only looking at the statistical significance of the product of A1, B1 and A2, B2, those mediation roots. You're looking at those and see if they are statistically significant, and then you infer presence or absence of mediation. All right. And therefore confirm or reject your hypothesis. That will be the transmitter approach. But the segmentation approach, you have to have several hypotheses and test individual roots. Root A, root B, I mean A1, A2, B1, B2, and C. And then make your decision.
Yeah. Hello, God. Hey.
Nimeongea nao
Hey.
jamaa akajitambulisha akasema sisi nadhani nakukumbuka. Kuna siku
Ameniambia ameniambia na kukumbuka huyo askari
Jamani, mwe makini kwa sababu hizi tuna records na sidhani kama tuna muda wa kufanya edit. Kwa hiyo siri zenu zinaweza zikawa exposed kwenye haya mavideo. Okay, so what is then where am I? I think I'm in recommendation number 3. Avoid the nomenclature of saying complete versus partial mediation. I've already discussed this because if you say there's complete or full mediation, you are excluding the possibility that there could be more mediators. That's all what this slide is saying. So therefore, use some alternative vocabulary, like saying indirect effects or direct effects, etc. In recommendation number 4, we advocate for the inclusion and estimation of the direct effect of X on Y when you're conducting your empirical tests for mediation effects. Okay. Why? Because if you don't do that, some erroneous conclusions about mediation effect may be drawn. Okay. So theoretically, excluding C complement signifies that a given mode of interest has exhaustively identified or mediation process explaining effects of X and Y. Okay, so if you exclude C complement in your regression mediation, you'll be assuming that there are no more mediation, which is not true, because there are possibility of having more other mediation which you did not uncover or which are not within the scope of your study. So it's always important to include it. Okay. Number 5, you're advised to abandon some of the methods like the BK methods in order to test for mediation effects. Okay. But you're recommended to use more advanced methods as I've listed them there. But you could use the BK, that's the Baron and K and whoever was that, Baron and Ken method. That's the BK method. Okay. Now the Baron and Ken method, that's BK, is essentially useful when you are conceptualizing moderation, trying to consider moderation, especially if you have single level models. You have only maybe one mediator. Okay. Then the Baron and Ken method can be very useful. But if you have several moderators, that would not work. Okay. Number 7, choose some explicit procedures over implicit procedure tests for mediation effects. Now, explicit means clear procedures, like, for example, taking the segmentation approach would much be better, while implicit procedures are brief and straightforward. Okay. That's just a recommendation. Okay. Then I think we're moving backward now to 6. This one concerns conclusions against mediation effects that you'll be drawing from non-significant Sobel test results. Okay. The recommendation is to interpret the results from Sobel tests with some caution, because the test, that is Sobel test, has lower statistical power. Okay. Recommendation number 8, again, forget the total indirect effect, examine specific indirect effects. I mean, when you have several mediators, mediator 1, mediator 2, mediator 3, there are 2 ways you could do. You can consider mediator 1, mediator 2, mediator 3 as one total indirect effect. So the suggestion here is not to bundle both mediators' effects together, but rather to examine each mediator separately, so that you are able to develop a much more meaningful discussion, but also make some appropriate evaluation and recommendation and some nice reporting. So focus on specific indirect effects above and beyond an evaluation and reporting of total indirect effects. Although you might report it, but your focus should be on specific indirect effects. Then we have a practice session here. Actually, this slide should have been forward. Okay. Let me see. Okay. Now, let me finish with this slide and then we go there. Now, the practice session, in the practice session, you're expected to be aware of these things here. The first thing to note is whether the direct effect C is significant, okay? That's very important because that will dictate what type of mediation is there. So it tells you what types of mediation or non-mediation you have based on that diagram I showed you. Okay? So, for example, if XB is significant, but C is not, you have indirect only mediation. This is just a reminder. If X and B is not statistically significant, but C is indirect only, and I mean, you have direct only, and therefore you have non-mediation. If neither X, A, B, and C is significant, which means they are both not significant, you have no effect. And also you have non-mediation, okay? But now here, very important, if both A, B, and C are significant, determine the significance of, I mean the sign, not the significant, the sign of the product of A, B by multiplying the three coefficients or by multiplying E by the mean value of A and B from the bootstrap output. You'll be doing bootstrapping in the computer. Okay? Now, if A and B and C is positive, then you have complementary. If they are negative, you have competitive. These are some of articles which I will show you later after if I forget, remind me so that I walk you through some of these articles that are doing mediation. Then of course you shall see some those who do some moderation and see some interpretations and how to read between lines and see things in real life, okay? These are key. Now, let's go back to the screen here. I want to do some practice. Let me see if you can see my screen. Can you see this screen? Hello?
Yes, doctor.
Yes, we can see.
It's
Okay,
okay.
see.
You can see it.
It can be seen, yeah.
Okay. Now I'll show you. Today I'll just use one software to show how you can actually do this. So I'll use Jamovi to show you how to do this. I've already loaded my data, sample data for simplicity. I have 1, 2, 3, 4, 5, 6, 6 variable here. So what you do, you come to this icon here, and then we can start with simple mediation here, and then we shall come to some advanced mediation modeling. Yeah, but let me just go with this first. Yeah. Now, I don't know what these data represent, but I'm just using them for the sake of demonstration. Okay. So what we'll do, let's just pick, let's say this one as your dependent variable, SVO, okay? And then let's just pick XP as a mediator. And then let's just pick this one as a predictor, which is so this is our dependent variable, which is SVO, or the Y for that matter. The mediator M is EXP, then the predictor variable, which is the independent variable X, which is the BH. Now, this will be your primary output, but you could do something else here and add more output. But you need to realize that normally you will have 2 tables. The mediation estimate table, which is showing the different routes, okay? And then the path estimate table. So you must use a software that will be able to produce both table. Path estimates table, and is actually showing you the path. This is BH. Actually, you could add, let's say, for example, labels, so that this, because you're more familiar with this nomenclature here, of A, B, C, B, complement, whatever, okay? Let's maybe add everything and then do some interpretation. You could also add some confidence intervals, so they'll be added there. Maybe decimal plots. Okay, the confidence interval added here. Okay, and then you could also calculate the percentage of mediation. That is how much mediation. That's based on the Sobel test. All right, this figure here on this right-hand side. Now you can do some, this is standard methods, okay? This one, but you can do bootstrapping, which is now what I was talking to you about, the other methods, which are more advanced. You can do some bootstrapping. Now this will take time. If I click this one here, we'll waste a lot of time, but you can do that on your own. But let's do some interpretation here probably, so that we see what we can do. Now, going back here, the first table is telling us about the mediation estimates. These are normal regressions with the expected values. For example, these are the kind or types of effects: the indirect effects, which is AB, direct effect, which is C, then the total effect, which is C plus A times B. And these are your estimates, which are your beta coefficients. And then these are standard errors. This is your lower confidence interval. This is your upper confidence interval, okay? All right. And then the Z and P value. Then this is the percentage of mediation, which means in this model, 15.2% of effects can be accounted in the indirect effect or the mediation effect, while 84.8 is part of the direct effect, which is direct, okay? Now, the path estimates are here also, in which case they show you the directions, that is BH to EXP, that is path A, which from our normal nomenclature, that will be exon M, using those symbols that we were using previously, exon M, that's A. Then this one, EXP to SVO, that would be M on Y, that's B. And then path C, that's C complement actually, that is from X to Y, BH to SVO, okay, so, and these are your, so if you're using your segmentation approach, you can easily now follow along and make some conclusion based on that, okay? But coming back to this table, A times B, that's your mediation. So you have to see if it is statistically significant, okay? You look at it, it's 0.39, which means it is not statistically significant, but the direct effect C is also not, okay? because this is 0.06. If it were 0.05, we could say. So technically, based on the information we have, we are not able to establish statistically the presence of mediation in this model. I hope you understand. All right. Now, next, let's look at the last example here. Now, using the same data, we could actually use the GLM model where we could load multiple mediators, all right? Multiple mediators. So let's say again, your dependent variable is SVO. Your mediator could be EXP. And then you could have this also as a mediator. Okay. Okay, so you have this model, but you must have a factor variable or a covariate at least. Now let's have a factor using, let's say, this. Okay. So that will be our model. And this is the summary information. You have two mediator in this case, M1, M2. And what they mean here, the full model, and then the indirect effects here are listed as well, and the path of the effect. Now, this would be a representation, which of course can be copied and put to your document, okay? But also it's possible to have some more complication. For example, you could have even 3 mediators. If you put this also here, then this will load. Of course, it's loading, it's taking time. It's loading, it's loading. So this is it, you see? You have this route. This route here also is a mediator, and this route also is a mediator. And then this one here is the direct route, okay? So I just wanted to show you that that is possible. You could also have, and actually the outputs are here, which we shall discuss later. So there are many possibilities, okay? There are many possibilities. You could have a model like this, depending on your level of theorization. So here you have multiple mediations and moderation within it, but I'm not going to discuss a lot those things here. Let me just go back and simplify it first, and then we do what we want to do, okay? Let's go back to, let's say, this one. This is what we've been discussing. All right, so we have 2 mediators, this and this. And then we have we could go to some options here down and produce some covariate labeling, labels. Okay, we need label and values. And then bootstrap percent. If you want to bootstrap, okay, the BC method you can do and bootstrap. Or the normal methods, or if it's none, etc., then you could also report the individual regressions down here. They'll be produced. And well, that's it. So going back to our result window here. You will see that you have the information, the model, the labels, and then the table here. in which case you have the indirect effects of the first mediator, the second mediator, okay? Then you have the other components, and then you have the direct and the total. Then you could have individual regressions here for each path. For mediator models, the regression results is here, the mediator models are here. And the full model predict SVO is also here. All right, so that's what you normally do. Let me just try to change this data. Ramagi, please do something there. All right, so some people are just crazy. Okay, so that's it. That's what you can do with this software. This is what is it? This is Jamovi, but there are other softwares. Well, with this also you can even go and use structural equation modeling and do through path analysis and do some interactive analysis. All right. Because mediation can be implemented through SEMI also, or structural equation modeling, okay? So that can be done. But if you want something nice, simple, put in your table, this is what you can do. And this is the software if you don't want some complication. Why am I saying that? Because if you want to use data, you have to do, you have to really engage your mind. ARA also will have to engage your mind. SPSS, you have to engage your mind also with AMOS and other software, especially process. Okay. Now, you can go those routes, but for demonstration purpose, I think for me, this is enough. Now, let me walk you through some papers. And then we shall have a few questions before we close for today, okay? Okay, are these clickable? Yes, I did some linking. I don't know what is happening. Let me see. Okay, they're not active. Let me go back, especially to the folder and check these individual papers and open them. This is 10 something. Okay. These articles here, you have this one, mediation article. And then you have this one. Then you have this one. And then we have this one also. This one, etc., etc. Now, let me share this, and then we make a small discussion here. So we have this, that, and this one. Share this for. Okay, I hope you can see. Now, for example, you see my slides? I think you see them. Can you see my paper? The paper I have posted.
Yes, yes, we can see them.
So this is one example of a paper, Impact of Entrepreneurial Leadership on Project Success, Mediating Role of Knowledge Management Process. See how nice that sounds. This is from entrepreneurship, leadership, etc. Now, out of this, of course, you have the abstract, and this is how actually you prepare your papers. You prepare a structured abstract. If you work in groups, that's much better. You have several authors. Now, originality. I'm just going to read you through this one here. All right. Let me pick some pen here or some highlighter. Okay. Originality, for example, yeah. Say the relevance of the research stems from the scarcity of research on entrepreneurial, what is that? Leadership, okay? While studies on the role of leadership as a predictor, see, of KM are significantly limited. Additionally, there is a scarcity of research on the impact of KM on project success. This is one of the areas of study that investigates the interrelationship among ELM, KM processes and project success. See, the processes is referring to, that's the mediation itself, okay? So out of this, you have the text there, the theorization there, the literature review, theorizing each variable. But I just want to take you to the output. See, for example, the hypothesis is saying there is a significant impact of entrepreneurial leadership on project success, which means this guy is using the segmentation approach. This is the C, all right? Then hypothesis number 2 must be down here. There is a significant impact of entrepreneurial leadership on a KM process. That is A, part A, that is X on M. There is a significant impact of KM process on project success. That's M on Y, okay? Hope you're following. And then lastly now, he states the mediation hypothesis. He say KM processes mediate the relationship between entrepreneurial leadership and the project success, okay? And this is his model. And these are the processes. So which means from this simplified model, he has 4 mediators. Hope you're following. Those are the processes, all right? While these are mediators, this is the direct route. That's the C complement, okay? The methodology is there, blah, blah, etc., etc. He's using smart PLS. So these are constructs. And then these are correlations as usual. Path coefficients as usual, you see. The T statistics, the P values, standard deviations, etc. Total effect, direct effect, indirect effect, etc. And then, so then he discusses the conclusions, and that's the end for that article. Maybe another article here would be this one, revisiting the relationship between corporate social responsibility and organizational performance, the mediating role of team outcome, okay? Now, this is another nice paper. Just want to show you how they look like. That's the model. You have the X variable, then the mediating variable, and then the Y variable. Team outcome, you have 1, 2, 3, 4, 5 mediators, okay? These are constructs, how he measured, and these are the reliability, the alpha, okay? Now, okay. This is the Cronbach alpha, this is the rho A, this is, these are critical ratios, the average variance explained, etc. The variables are there. And these are the descriptive statistics. Now, this is for a local criterion, the ratios of correlations, actually. And then these are paths for each of those. And some were significant here. All right, statistically significant. So which means his discussion will be rich. Then he discusses his mediation analysis, etc. So Then maybe let me look at another one here, the last one, before we invite some questions. This one, interpreting the impact of knowledge management processes on organizational performance in Chinese higher education, mediating role of knowledge worker productivity. So you have a paper there. Anyway, so do you have questions? These are hypotheses. Any questions, any comments, probably? That's the model. Do you have questions? Let's pick questions now. McGill, maybe start with Frank McGill if you're still out there.
Yes, Doctor, I'm present. Thank you very much. I've got 2 questions.
Yes.
One is, what exactly are the difference between the moderator and the mediator? Because I'm still confusing on these ones in terms of their functionalities in any constructed model.
Okay, let's start with that one first.
Yeah.
Let me answer that one first.
Yes.
You mean the meaning of those two, moderator and the mediator? Okay, so moderator is a variable that affects an existing relationship between X and Y. All right. So yes. The moderator tends to affect the way effects are transmitted to Y, from X to Y, okay? So the moderator could be enhancing, for example, that is increasing the size of the beta between X and Y, which is what we call as enhancing moderator or moderation. It could also be buffering, that is the opposite of enhancing, which means it is reducing, but also it could be conflicting, okay? Maybe it is reversing the sign. Maybe the relationship between X and Y is positive, then when you put the moderator, the relationship becomes negative, etc. So moderation is on for whom is the variable, for whom I mean for which variable is the moderator acting. But when you talk of mediation, actually you are trying to explain how effects are transmitted between X and Y. So it's about how, okay? It could be on several levels. It could be complementary. It could be, what's the other one? Complementary or conflicting, okay? Okay, complementary or competitive. If the sign is positive between the directions, then it is complementary. That is, if the relationship for the direct route and the indirect route are both having the same sign, we say they are complementing each other to facilitate the effect between X and Y. But if the effects, I mean, the sign are different. One is negative, the other is positive, then they are contradicting each other. So they are competitive, all right? So the ultimate total effect will depend on the size or which line of effect is the strongest. Is it the direct or the indirect? So that's the distinction between moderation and mediation. I don't know if it's clear.
Yeah, clear. Yeah, the second one.
Yes.
The second one is, I've seen most authors, especially in the structural equation model, yes, they try to include both the moderator and the mediator. So I don't know, what are the logic behind of including both concurrently in the model?
Oh, okay, that one. Let me take you to this software back here, and then I'll demonstrate to you something here. I think did I forget? Maybe. Where is this software?
And then somehow it becomes difficult to interpret those two concepts at the same time.
Actually, it's a bit advanced, but it can still be done. Okay. So, for example, let me. I want to see my. Where is my this window? Okay. So, I want to share this one. Now, from this, for example, here, okay, it's possible to have moderate. See, for example, in this one, you have mediation, but coming down here, you could actually have moderators. So you could have moderated mediation, okay? For example, these are mediators. Let's say, for example, this is this and this. In this case, where's the diagram? I want to see. This is mediation, okay? Simple mediation. This variable is mediating the two, okay? But let's say we have one more variable somewhere here. This one, okay? Now, this could be you see, you have this and this and this. You have this as a mediator of both this relationship and this relationship, okay? So that's a single mediator, but for two relationships. That's one possibility too. But it's also possible to have the following. You have mediators, and this is where you have two mediators. My data here are very limited, so I'm trying to. You see, this one here, you have this is a mediator, this is also a mediator, and then this is an independent variable, and this is an independent variable. But let's say we want to put some moderation, all right? Moderator here, let's take this one. Okay. You see this? Maybe let me simplify this and remove one of these. This one, go. Now, this one is what we call as moderated mediation. Are you following? Moderated mediation. This is a mediator, BEH. Prime is a moderator. And it's actually moderating this relationship, and this relationship. So this is complex. This can be done in this software, okay? As you see, the results are actually, they're not popping up because probably data limitation, I think, because the data are very few here. But the result would pop up, would come as usual. In SAME also, you can do that. All right. Or we can simplify this. So this is it. This is also possible. You have a mediator here and a moderator somewhere here. So that's the idea. So it's possible that it depends on the theory. So when you are theorizing, try to be as open as much as possible, as much as the literature is leading you. The literature should guide you and lead you. Don't drive the literature. The literature and theory should drive you so that you come up with reality or something that is close to reality. If the literature is indicating the presence of moderator and mediator in the same model, you should do that. If it's only mediators, you should do. So don't just choose a simple thing for the sake of simplicity. Let's pick some more questions. Do we have some more questions? Hello?
Yes, Doctor, I have a question.
Yes, this one, the last one, yes.
Okay, in the statistical estimation you gave us in the interaction between X and M, in the model you drawn like Y is equal to AX plus BM plus CXM plus E. That's when X is a single independent variable. So if we have more than one independent variable, like say X1, X2, X3, how will that kind of model be?
Okay. I'm not sure if this will support for this will not work for a software like this one, but that can normally be done using same structural equation model. When you have multiple dependent variable, we normally use structural equation modeling, okay, which is this one here, where you can do that, okay? But also, so you can use Amos, you can use these softwares, etc. That's where you can do the linking if you have multiple dependent variable, okay? Is that clear? So for example, in this one, path analysis, let's say, for example, this is your endogenous variable, the first one. So which means you could have several endogenous, and you could have several, actually here they need some categorical variable or ordinal variable. This one. Well, this may take time probably, or probably due to data limitation. So it will not load very fast. Then you may have some exogenous, then probably some multi-group, etc. Well, so it's possible to do that, but you need to do some, you use some other formula. I mean, some other some more advanced module like semi-structural equation module. Okay. I don't know if I have satisfied your question. Yes.
Yes, thank you.
All right. Any other question? Okay, let's end there probably for today. Unless if there's any question. Do we have more questions? Thank you. So tomorrow we will be finishing the rest of the other training. And then we will wind up our seminar at the same time. And then of course we shall use the same link. This is not working because the data I'm using is not big, because semi will normally require a bigger sample, 200 plus. Now this is small, it's only 100. All right, so thank you very much for coming and for stopping by.
Yeah, thank you. Thank you.
Okay, thank you.
Thank you, sir.
Thank you.